Hello and welcome back again. We have been discussing the various methods of braking. We discussed regenerative braking and then dynamic braking. In this brief lecture, I will explain the third method of braking, that is plugging. So, as the name suggests, plugging means interchanging the terminals. So, in this method, what you have to do, this is the normal motoring operation where supply voltage is more than the back EMF. Energy comes out from the power source and it is absorbed by the motor and converted into mechanical energy. So this is the normal motoring operation. In plugging, what you have to do is that you have to simply interchange the supply terminals. You have to reverse the terminals so that the polarity of the supply voltage now it reverses. So how the equation will change? Normal equation for the motoring operation was V upon K minus RA upon K into I, normal operation. What you have done here, you simply reverse the supply terminals. So you have reversed the polarity of the supply voltage. So it has become minus V upon K minus, and again if you do it, then what will happen when you simply reverse the terminals not connected into resistance here, then what is the situation? You will have the current equal to V plus E upon R. You apply Kirchhoff's voltage law here. These two voltages in the same direction. So the current that will be flowing here, this current IA will be equal to V plus E upon RA, and V plus E upon RA means in the normal operation the back EMF is close to the supply voltage, so it is close to twice V upon RA, so that will be twice the current that the motor draws when directly connected to supply voltage. So it is twice the starting current. So even starting current, which is 20 times the full load current, is not permissible. So we cannot permit twice the starting current also. So you have to do something. You have to add some resistance here. So while interchanging the connection, you add a resistance RB, braking resistance here, so that the current is limited to safe value. So in that case, the equation will be like this: minus V upon K minus RA plus RB. RB is the braking resistance that we have connected here, external resistance, upon K into IA. So this is chosen such that current is within the safe limits. So now let us see. This is the normal characteristic of the motor at rated voltage, and you are operating somewhere here. Suppose that the rated current was drawn by the motor under normal operation, and you decided to stop the motor. And to stop the motor, you are using the method plugging. So what we have done, you have just reversed the terminals and connected the resistance RB across this. Equation becomes like this. So the no load speed, which was V upon K earlier, now it becomes minus V upon K, equal and opposite. So this means that this is the y-intercept, no load speed minus V upon K, and slope has increased to RA plus RB. So this is the characteristic now. It is again a straight line, y equal to mx plus c. So this is a new characteristic of the motor under this changed condition. So this is operating point. As soon as you made the change, the motor speed will not change instantaneously. It will remain same. So at the same speed on this operating point, on this characteristic, this is the operating point. So the operating point will shift from this point to this point immediately after we have made this change in the circuit. So now you can see that current has reversed. You have made this current to be twice the full load current, so the torque will also be twice the full load torque. So you have reached here. Because of this negative torque, the motor will decelerate and it will stop at this point, provided you have removed the supply at this instant. Otherwise, you can see that even at zero speed, the braking torque is there, unlike the dynamic braking where at zero speed the torque was zero. so motor will stop by itself. But here, if you don't switch off the supply, because of this torque, the motor will accelerate in the reverse direction, and finally it will reach somewhere in the this quadrant. So what you have to do is that you want to stop the motor, you have to disconnect the supply as soon as the motor speed falls to 0. You must have some sensor that senses the speed of the motor, and as soon as the motor stops, the supply should be disconnected from the source, from the motor. So this is what is known as plugging. So one advantage of this plugging method over dynamic braking is that you don't need to have a variable braking resistance, because in the dynamic braking you have seen that as the motor speed reduces near 0 speed, the torque was very small, so motor will take a longer time to stop. But here in this case you have just disconnected reversed the terminals and connected this resistance RB, and enough braking torque is available even near 0 speed. So you need not to reduce this resistance anymore, just one resistance will be enough. So this is more convenient as compared to the dynamic braking method. But what is the drawback here? Drawback here is that the power is released by the source. You can say now this is energy is released by the motor, the kinetic energy is released by the motor, and it is dissipated in the armature circuit resistance, it is dissipated in the braking resistance, and this voltage source will also release energy. So this means that power source is also supplying energy during the braking operation. So the energy wastage is much more as compared to dynamic braking. So this, you can say that this method of braking is the least efficient method, because not only the energy stored in the system is wasted, some extra energy is also released from the source, and that is also wasted in the resistance in the form of heat. So this method is the least efficient method, but it has a convenience that you don't need the variable resistance across in the motor. So this is the advantage of plugging over dynamic braking, but the drawback is that it is least efficient method. So every method has certain advantages and certain disadvantages, and according to need you have to choose any of the 3 methods for braking purpose. So that is all for electric braking of the